Hey, have you ever stopped to think about what's actually powering your every single move? Your every thought, every heartbeat? It's something we do thousands of times a day, totally on autopilot. Respiration. But you know what? It's so much more than just breathing in and out. It is the absolute engine of life itself. And today, we're going to pop the hood and see exactly how it works.
So, let's start with a mystery we've all experienced. You're running to catch a train, maybe chasing your dog across the park, and suddenly, you're totally out of breath, gasping for air. It happens to everyone, right? But what is really going on inside your body to make that happen? That is the big question we're going to unravel today.
Our whole investigation actually kicks off with this story about a kid named Bujo. He was late, sprinted for the bus stop, and when he finally got there, he was breathing super fast. His grandma asked him why, and that simple question really got him thinking, why does running do that to us? So we're going to follow Bujo's curiosity and get to the bottom of it.
All right, to solve this, we need to shrink down. I mean, way, way down, smaller than the eye can see. We're about to take a journey deep into the microscopic world of our own bodies to find these tiny little power plants that keep us going. That's where the real answer is hiding.
So everything that's alive, you, me, a tree, the tiniest little microbe, is made of cells. You can think of these cells as tiny, bustling factories. And just like any factory, they need a constant stream of energy to do all their jobs. And I mean all of them, helping you run, digest your lunch, or even just dream at night.
So, where does all this energy come from? Well, it comes from the food we eat. But here's the thing. Your cells can't just use a piece of pizza directly. They have to unlock the energy that's stored inside it. And that special unlocking process, that's called cellular respiration. It's how our cells turn food into fuel they can actually use.
Now, our cells are incredibly clever. They're not a one-trick pony. They've got two different ways to get energy from our food, specifically from glucose, which is just a simple sugar. The main event, the most efficient method, is aerobic respiration. This one uses the oxygen we breathe to get a ton of energy. But what if you're low on oxygen? Well, our cells have a backup plan. Anaerobic respiration. It's a quick and dirty way to make energy when oxygen isn't around.
You know that feeling? That deep burn in your muscles when you're in the middle of a really tough workout? That's anaerobic respiration right there, happening in real time. When you're pushing your body to its limit, your muscles need energy faster than your lungs can supply oxygen. So they flip the switch to this backup mode. The only catch? This process creates a byproduct called lactic acid. And when that stuff builds up, bam, you get that all too familiar muscle cramp.
Okay, so we've established that our cells are absolutely desperate for oxygen to work at their peak. But how does that oxygen get from the air all around us into those billions of tiny cellular factories? It's time to zoom back out and look at the incredible piece of engineering that is our own body and the mechanics of breathing. Okay, take a deep breath in with me right now. Feel that? When you inhale, it's a very active process. Your ribs actually move up and out, and that big muscle under your lungs, the diaphragm, it pulls down. All of this makes more room in your chest, creating a vacuum that just pulls air right into your lungs. It's like this perfectly coordinated dance happening inside you. And exhaling is basically just the reverse. Everything relaxes, your ribs settle down and in, and your diaphragm moves back up. This shrinks the space in your chest cavity and gently pushes the air back out of your lungs. Inhale, expand. Exhale, contract. It's so simple, but so brilliant. So how often are we actually doing this little dance? Well, when you're just chilling out, maybe sitting and listening to this, you're probably breathing somewhere around 15 to 18 times a minute. That's your body's resting state, just getting the baseline amount of oxygen it needs. Just tuck that number away for a minute. So what's actually changing with every breath? Let's look at the numbers here, because they tell a really cool story. The air we breathe in is about 21% oxygen, but the air we breathe out, it's down to about 16%. So where'd the rest of it go? Well, it got delivered to your cells. And in its place, the air we exhale is full of carbon dioxide, the waste product from all that cellular work. It goes from almost nothing in the air we inhale to over 4% in the air we exhale. It's this amazing silent exchange of life.
Now, it's easy for us to think that lungs are the only game in town when it comes to breathing. But hold on, because nature is way more creative than that. Let's take a quick tour of the incredible and sometimes weird ways other creatures get the oxygen they need to live.
Insects are basically like something out of a science fiction movie. They don't have lungs at all. Instead, they have these little holes along the sides of their bodies called spiracles. These openings lead to a whole network of tiny air tubes called trachea that deliver oxygen directly to their tissues. No lungs needed.
And it gets even wilder. Earthworms, they literally breathe through their moist skin. How cool is that? Fish, of course, have their amazing gills, which are experts at pulling dissolved oxygen right out of the water. And then you have amphibians like frogs. They're the ultimate survivors. They can use lungs when they're on land and breathe through their skin when they're in the water.
And get this, plants breathe too. I know we always think about them taking in carbon dioxide for photosynthesis, but they also respire just like we do. It's how they get energy from the sugars they make. Their leaves have these tiny little pores called stomata for gas exchange, and even their roots need to breathe, pulling in air from tiny pockets in the soil.
All right, let's bring it all home. We've gone from the tiniest cell in our body to the roots of a giant tree. And we've seen that this one process, respiration, is absolutely fundamental to all of it. So now we can finally give Bujo a clear answer to his question.
And here we are, full circle. Why do we breathe faster when we run? Well, it's actually pretty straightforward now, isn't it? Running is hard work, and that work requires a huge amount of energy. To make that energy efficiently, our muscle cells scream for more oxygen to power that aerobic respiration. Our brain picks up on this urgent demand and tells our lungs, hey, speed it up. So we breathe faster and deeper to rush more oxygen to our muscles so they can make more energy. It's this beautiful, perfect feedback loop that keeps us going.
When you boil it all down, it comes to this simple but really powerful truth. Respiration is the key that unlocks the energy trapped in our food, and that energy, that's what we call life. Without it, survival is simply not on the table.
So, the next time you're outside and you take a really deep breath, just for a second, remember this. You are taking part in a global symphony of life. That same air you're breathing in is also flowing through the leaves of a massive tree, through the gills of a fish deep in the ocean, and through the tiny spiracles of an ant. We are all connected by this invisible, life-giving process. It really makes you think, if we all depend on the exact same air, what does that say about our shared future?